If the light from some space object took billions of years to get to us, then we see that object as it was billions of years ago. In this way, we can peer back in time and literally see the past in motion.
The James Webb Space Telescope has just stunned astronomers with a discovery at the very edge of the observable universe. Scientists have identified a galaxy so incredibly distant that it's now challenging our understanding of cosmic history. Here's why this is mind-blowing. When we observe distant galaxies, we're actually looking back in time. Light takes time to travel across the vastness of space, so the farther away an object is, the older the snapshot we see. For example, observing something 1 light year away shows us how it looked 1 year ago. Push that distance to billions of light years, and we're seeing the universe as it appeared billions of years in the past. Using powerful telescopes, scientists have already observed regions of space over 13 billion light years away, helping to construct a standard model of cosmic history. According to this model, the universe's earliest epochs, known as the Dark Ages, were shrouded in hydrogen clouds long before stars or galaxies existed.
We live in the stelliferous era. Somewhere between 10 and 1,000 billion trillion stars fill the observable universe with light. But there was a time before the first star ignited, a time we call the cosmic dark ages.
At the very beginning, cosmologists believe all matter and energy were compressed into a tiny, infinitely dense point called a singularity, the origin of the Big Bang. Current physics cannot fully describe this state, making it the ultimate limit of how far back we can peer in time. For decades, this framework suggested there was nothing before the Big Bang. But the James Webb Telescope is rewriting that story. Its early observations suggest that the universe we thought began with the Big Bang may actually have been preceded by a strange, earlier cosmos. This revelation has scientists reconsidering long-held assumptions about the very origins of everything. Before Webb, the most distant confirmed galaxy was GNZ 11. Yet Webb's early data has uncovered dozens of galaxies farther than anyone expected, with some pushing beyond redshift 14, a distance thought previously impossible.
Z stands for redshift. You see, because the universe is expanding, light traveling through the universe over very long periods of time gets stretched out to longer and longer wavelengths, which consequently makes the light more red. That effect is known as cosmological redshift.
These findings not only extend the known frontier of the universe, but also raise profound questions about the timeline of cosmic formation and whether the universe had a pre-Big Bang history. After careful spectroscopic tests, which precisely measure the distances of galaxies, the current record holders for the most distant confirmed galaxies are MOMZ 14, JADES GSZ 14, and JADES GSZ 13, with MOMZ 14 taking the lead at a redshift of 14.4. This means we see it as it was when the universe was only about 280 million years old. Yet, there are other candidates with redshifts as high as 16. If confirmed, these galaxies would push the limits of our standard cosmological models, which describe how the universe formed and evolved. Spectroscopic confirmation is still pending for these extreme cases. Here's the truly remarkable part. The deeper James Webb looks into the early universe, the more galaxies it finds. Each new observation seems to uncover galaxies farther away than ever recorded, continuously breaking previous distance records. Recent Webb data has revealed galaxies at redshifts between 17 and 20, taking us farther back in time than any galaxies previously observed. Even more astonishingly, the telescope has detected 6 galaxies at redshift 17, 3 galaxies at redshifts 24 and 25, an extraordinary galaxy at redshift 32. A galaxy at redshift 32 would have existed roughly 98 million years after the Big Bang, a discovery that could seriously challenge standard cosmological models. According to astronomer Perez Gonzalez, these are the deepest observations Webb has ever made, deeper than anything before by a significant margin. If these galaxies truly exist at these distances, it implies the early universe was far more active in its first 200 million years than scientists previously thought. This contrasts sharply with the expectations from standard cosmology, which predicts that the first 100 million years after the Big Bang were a quiet, dark period with no stars, no galaxies, and almost no light, a time known as the Cosmic Dark Age.
If we look beyond, both in distance and in time, there is nothing, darkness. For the 100 million years or so between the formation of the first atom and the formation of the first star, there was no light source in the universe. These were the cosmic dark ages,